We know that it takes 3 line segments to make a triangle. What we need to look at now is it any combination of 3 edges that make a triangle, or is there a specific relationship we need to look for between those line segments? Let's try experimenting with a few different lengths. Here we have edges that are 4 units, 5 units, and 6 units long. If I take 6 as my base and use 4 and 5 as my edges, we can see that those do connect to make a triangle. So 4 units, 5 units, and 6 units will make a triangle. Well, let's change it up a little. We're going to keep our 6 unit base, but this time our edges are each going to be 3 units. If we move those to the edges, we can see that we can connect them, and we can keep turning and rotating them and moving them towards each other. And they do eventually touch, but the 2 3 units don't give me any height over my 6 unit base. So 3 units, and 6 units would not make a triangle. Well, this time we have a base that's going to be 8 units, and we want to use edges that are 4 units and 3 units. If we take those to the corners and try to connect them, we're going to keep turning our 3 units and our 4 units towards each other. As we do, we get closer and closer to the base, to the point that these are now flat along our base and they've never reached. So sometimes it worked and sometimes it didn't. It worked for our 4 unit, 5 unit, and 6 unit triangle. It almost worked for our 3, 3, and 6 unit triangle, but it didn't work for our 3, 4, and 8 unit triangle. Why do you think that is? The key to deciding whether or not 3 sets of edges can make a triangle comes down to the length of the shorter edges. The sum of the shorter edges should be greater than the length of the longest edge. If we look at what we made, let's test it out. Here, our longest edge was 6 units, and our shorter edges were 4 units and 5 units, and this one made a triangle. If we test it out mathematically, we need to find the sum of our shorter edge. So the sum of 4 plus 5 gives us 9. 9 is greater than 6, so 4, 5, 6 will make a triangle. In our second trial, our longest edge was 6, and our 2 shorter edges were 3 each. 3 plus 3 equals 6, so that means the sum of our 2 shorter edges is equal to the length of our longest edge. And as we can see, these 2 shorter edges were able to meet, but they didn't have enough combined length to give us any height over our longest edge. On our last one, our longest edge was 8, and our 2 shorter edges were 3 units and 4 units. If we add together our 2 shorter units, 3 units plus 4 units, 3 plus 4 gives us 7. 7 is less than 8. So that means these edges would not be long enough to make a triangle. And as we can see, these 2 shorter edges weren't even able to meet in the middle, let alone have enough height to make a triangle. Let's test our new rule with a few other sets of edges. Here we have edges that are 5 units, 7 units, and 10 units long. If these are going to make a triangle, the sum of 5 and 7 needs to be greater than 10. Let's go ahead and add together 5 and 7. 5 plus 7 gives me 12, and 12 is greater than 10. So when I take these 2 shorter edges to the corners, they should make a triangle. And sure enough, we can see they have enough combined length to meet above the base and create a triangle. This time we have side lengths of 3 units, 4 units, and 10 units. If this is going to make our triangle, the sum of our shorter edges, 3 units and 4 units, needs to be greater than our longest edge of 10 units. When we add together 3 plus 4, that gives us 7, and 7 is less than 10. So 3, 4, and 10 should not be able to make a triangle. Sure enough, when we try, 3 and 4 don't even have enough combined length to meet, let alone create height to give us a triangle. So no matter what lengths we're working with, in order to make a triangle, the sum of the 2 shorter edges needs to be greater than that of the longest edge. Check out the other videos in our playlist and don't forget to click on subscribe. Thanks for watching!